Hello there folks, Cranky Old Cuber here again. Going to do a bit of soldering today. I've got this modular synthesizer kit. It's a Eurorack kit and it needs a power supply and case. We've got the case sitting right here and the power supply components are in this box, and we're going to get to it and start soldering. This is the first step. I've got a bunch of modules to build, but need power first. So I could use the power supply that's sitting over here on my bench, but Eurorack modules have this particular plug interface, and I just didn't feel like fooling with trying to hook up the power supply and get power into it when I've got this handy dandy circuit board right here with, these are the power connectors. Let me pull one out here. See, the cables plug into a thing like this. It's going to be hard to mock that up, so I'm just going to build the power supply. So let's get all the parts out. I'm going to get the case out of the way. We've got our power supply board. This is a pretty simple board. Let's see if we can get it out of here. There we go. Yeah. So this guy has a whole bunch of power ports on it, right? And then we got a power supply module here. Power comes in through this guy, and there's a little switch somewhere that you can turn it on and off. And this just mounts down here inside the case. And then your modules mount to the front here. And as I build this, we'll see more. So I'm going to get into it and start soldering. One thing, my eyes are super old, so I do most of my soldering under the microscope here now because I have to get so close, and it's way easier and more comfortable. So I'll be doing that a bit, but I'll give you a view under the microscope and you'll be able to see. So let's pour out all the parts, do a little organizing. So the power adapter is this guy. It looks like it'll take any 12 volt DC power adapter. I could run power in from the power supply to this thing, which I probably will to test it, but I want this unit to provide power to the modules. And what is this guy? This is a 12 volt 1 amp power supply. Yeah. And I can't tell if it's regulated or if it's a switch mode, but it doesn't matter because this will do regulation. So the thing about clipping leads is I used to just clip them willy-nilly, and then they started flying around, and then one of them hit me right above the eye as it flew off, and I decided I was going to be a little more careful. So that's what I'm doing. All right, let's take a look at these joints. Those look pretty good. Those look pretty good. Yeah, that looks right. That looks right. Good, looks good. How do they look from the top? Look, there's solder on the top too. That's how these through-plated holes work. Yeah, all right, those are on. Pin 1 is 12, minus 12 volts. This red dude, so the red stuff here on the cable means that this is pin 1 down here. I'm going to do one pin on each of these until I get it hooked up. All right, well, we're going to go into quick soldering mode. put the capacitors in. Okay, I believe we are to the point where all we got left is these jacks for the box. So, all right, let's cut off some leads. You mostly don't want them sticking out because it's a little unsightly, but you also don't want it sticking out because it might short something that you don't want. All right, jacks. There. All right. I believe that is the soldering. Well, it's the soldering on the board. All right, so got the board together. Everything is on there and ready to go. It's ready to go in the case. I cleaned it off really well with some isopropyl alcohol and a little scrub brush. Looks like a toothbrush. So you want to clean the rosin off for two reasons. One is it's could be electrically conductive, which could cause shorts between pins. So if you clean it off, you won't have that. The other thing is it's really sticky. And I don't like the sticky. The sticky really makes me, I don't like it. It's going to dry for a while before we do any testing on it. But once it's dry, we'll examine it under the microscope, make sure all the solder joints look good, touch anything up if it needs, and then we will do a little bit of testing for continuity and also to make sure we don't have shorts between pins where we don't want shorts. Then I think we can power it up. For now, what I'm going to do is I'm going to work on this jack and the switch. And let's get the case and take a look at it because, see, it's got a hole for the switch. So that'll just, I believe that just snaps in. Looks like. Yeah, that's just going to snap in. And then this guy has a nut. Okay, case is ready to accept our power supply board. This should boot up and the LEDs should light up, and then I should be able to probe, and I'll go ahead and change my probe to volts. Let's turn it on. Hey, we got LEDs. That's a good sign. All right, so let's see what we got going to these terminal strips. I believe all this does is it routes the power from here to this terminal strip. I don't think any of this goes out through here. I'm pretty sure that what we're doing is just passing the 12 volts in down. So if you have additional boards like this, you can just connect them up top to bottom. All right, so we'll put our thing in there. We are getting 12.0072 volts, but yeah, we're getting 12 volts directly out of there. That's no big surprise. Okay, so let me jam this onto, I'll just jam it onto the ground here because that ground is the same everywhere. Our 12 volts is giving us 12.084. That's pretty good. Our minus 12 is giving us minus 12.0639. So that's pretty good too. Turn on the power from the power supply. We are drawing 0 amps. It's at 12 volts. Turn it on. And we got power. Everything's working. So yeah, that finishes this up. The case is ready to take modules. Power's working. Everything looks good. I think voltage control oscillator is the next thing I'll build and install in the case, and we can play with that. So thank you for watching, and see you at the next one. Cheers.